Everybody wants it. The mindset was from, I think, 2010 that a lot of companies, especially a lot of managers, wanted test automation to be done so that quality is going to rise, a lot of good things will be happening, and maybe manual testers won't be needed anymore. The other thing is that DevOps is a present thing, and it's going to be showing up in a lot of slides in this presentation. But for the most part, the first thing that we need to say is that DevOps isn't test automation. It's not strictly that. It's something that enables test automation to be successful. The other thing is, this was a mindset shift because initially, all these companies in the world, or basically any company that we can think of, they didn't think of testing as something really important. But this changed in, as I mentioned, around 2010, or maybe a bit earlier. But yeah, and even with this mindset shift, there was a lot of rocky road to be covered. A lot of people were selling, let's say, false solutions, bad ideas, bad products, whatever. There was a bunch of conning in the market, but thankfully we survived that. The other thing in the current situation of test automation is that a lot of things are returning. Say the Selenium UI that's getting traction again. It's raising back from the dead, basically, because previously there was a lot of technology that it didn't support, and it's now getting a bit, well, more up to date. And the other thing in test automation in 2019 is that the market is very fragmented. And a lot of you might know this because if you work with JavaScript or have worked with JavaScript before, you might know that every single day there's at least 2 frameworks coming up and like 5 different frameworks getting, well, into the grave. So there are a few issues, as I mentioned, but the biggest issue here in test automation is that the expectations might be unrealistic. A lot of managers and a lot of companies might think of test automation as a completely magic wand, something that might solve everything. This was about test automation first, then it was about mobile apps, it was about cloud, and now it's about AI. But for test automation as well, this is a present thing. And as mentioned, DevOps is still a leading thing in unrealistic expectations and how the industry is. And the really, really big or key problem in test automation currently, even now, is the maintenance of test cases. These test cases might, let's say, degrade over time, have some bad regressions, have some issues. There might not be, let's say, good changes. And with that is also a false sense of security, because as long as you don't automate everything that's, well, let's say, automatable or should be automated, even then, if you have some of these test cases done, you might see that everything is fine, nothing is going to be broken, everything is going to be okay, the release cycle is going to be fine. And with that also comes wrong tool selection. Usually, some people get vendor logged into, let's say, I don't know, HP solutions, then can't move on to another solution because at that point, a lot of their testers are just about that. They know that, just that, nothing else. And then, basically, it's a bad place to be in because you can't move around or move out of that too easily. So, unrealistic expectations. The very first thing is that untestable by design. A lot of code, as I think everyone has seen, is code that's untestable because they don't follow the clean code principles, they don't do any code reviews. They might do code reviews, there might be a lot of things, but the fact is, some of the code is untestable by design. And this leads into testing as an after or non-thought, because if someone writes non-testable code and someone didn't care enough to write testable code, then testing really is going to be an afterthought. Nobody's going to bother with it. And until issues happen, testing is not there. After the issues, oh, we need testing, we need unit testing, we need everything. And this ties back into DevOps and full stack and cross-functional people as well. You can't expect a DevOps engineer to be, say, doing test automation perfectly. You can't expect a developer or a software architect to actually do perfect UI automation. You can't expect these things. Some companies do, but even then, it's not a thing that you should expect or companies should expect. And the other thing is that manual testing is basically a must in every field that I know of. But in contrast, manual testing might be the most prevalent and the most, let's say, used testing solution or methodology. They might not be using automation, even though automation is being well picked up, wanted, needed. And the other thing is return of investment skimming. If you don't invest enough into testing, if you don't spend enough on knowledgeable testers, if you don't spend enough on the environment, you don't have enough DevOps engineers, you don't have enough maintenance, then you're going to have a bad time. So on the case of maintenance of existing automation, it's budget consuming. At least 30% is going to maintenance of existing test cases, and the bad thing is that this might grow if we don't take care of these soon. This is a growing concern, and if we really don't do anything about it, there might just be a few people who know, let's say, maybe integration testing, maybe with one technology, and then you find out that maybe your company is understaffed, maybe you don't have enough people to fix these things anymore. And the other thing is that there might be false alarms, flying blind, because if these test cases might be working, it still might be assert true truths or similar. The other thing is brittleness and flakiness, which still ties back into DevOps. As you can see, this lovely triangle, getting into the middle is really hard, usually impossible. So test automation, false sense of security. There's basically the pesticide paradox. Everyone knows that even if you apply enough testing into one direction or one place or one cluster, everything else might still have bugs. On the program correctness end, you can never be sure that the program is perfectly working fine. You would need to reason about it, which is not something that a lot of people do or a lot of companies invest in. The other thing is that the uncertainty is going to grow. These things are, let's say, the source of fear, and fear is a bad thing. We're testing to avoid fear. Now, after discussing test automation, we can discuss about AI a bit. The very prevalent thing is that hype is present. Hype, hype, hype. Every single time I can hear about AI, it's always hype. 270% growth in 4 years. I think this is I think Gartner's statistic from 2018 or 17. And there's a tremendous potential and a lot of better than human fields. A lot of this was covered in all the other presentations here as well. We've heard a lot about this, so I might not linger on it too much. But there's a really bad thing, and I think that this was covered in Tariq's presentation as well. There's a lot of mystification and skepticism related to the AI field. It can be solved really easily if we're transparent about it, if we explain things, if we don't say, cover up things. But this is going to lead into the next AI winter, and it's going to happen either if we want it or not. If we keep pouring money, unlimited money, or at least near unlimited money, near infinite money into AI solutions that might not be existing or might not be what they make it out to be, then in the end, it's going to end up in the AI winter. It already happened twice, it's going to happen again. The question is, who's going to survive and what's going to be the end result of this, let's say, venture? The other thing is, as mentioned in test automation as well, there's a lot of snake oil vendors. We can see that in the internet and a lot of places there might be bad solutions, not so nice solutions, or just outright mystified solutions that don't show what they have. They cover it up, they don't show it. They just have a lovely spiffy page, please use us, use everything from us. And then there's the technological limits, because most of the things that AI can do right now is something that humans might not be too good at. Pattern recognition that we might not recognize, or similar. But then there's a technological limit to, say, actual human intelligence, intuition, these things. It could make, well, it could be worked, or it could be made to work, but it's a lot of effort and a lot of time, and again, a lot of money. So there's a lot of available venues for AI, and you've also heard about this again. And I highlighted predictive analysis because this is the key thing that we're going to be talking about now. The other things are software development improvements. Everyone heard that. You could use it in unit testing, where it might select a few tests that might be covered in code changes. You might have also heard about image recognition, where you can say that, oh, this is a cat. Fine. Self-driving cars and robots, Elon Musk, we've heard about that a lot. Chatbots, not too important. If I can say Amazon Alexa, but that's it. I'm not going to advertise anybody. So this might be a new approach to QA. We might do things differently in the future, basically be robot-driven. But right now, we're in kind of the redundant past and the seamless today-ish phase, somewhere in between. There are a few existing AI solutions, and I think that these are promising. These fields are being covered by a lot of companies, and a lot of solutions are being provided. The thing is that everyone, basically everyone that I found, provides self-healing in some way or form, but not the other fields. So in this regard, because everyone else does it, why not do it again? Why not do it more? Applying AI to test automation. As mentioned, there are a lot of risks and pitfalls. And as with Murphy's Law, if something might break, it's going to. If something goes wrong, it's going to go wrong, and it's never going to be nice or good looking. Life is ugly, and software development is hard. If you fail fast, you're going to get better results. That's a given thing. But in the case of AI, there's a lot of misinterpretations, and as enumerated here, the unrealistic expectations we don't escape ever. We're trying to, but sometimes we can't. It's still in the early stages for testing, and it might be, let's say, easier to ditch sometimes. But I think that we should embrace testing, AI in testing, because it's a really good thing. Catch-22 of early adoption is basically the same thing as the early stages. But again, if we do overcomplication or blind trust, we're going to end up bad. Management and budget. This is where the ugly things start showing in the case of companies. Some of the companies think that you don't need to invest too much or too much time, too much money into the solutions. The problem is you need to. It's a long-term solution, it's a long-term investment, and if you don't do it the right way, you're not going to have results. You're going to have a lot of disappointment, which leads into the AI winter. The good thing is that there might be better algorithms in the long run, but for now, there might be some less than better algorithms, maybe in some fields. But again, the most outstanding thing is that nobody is going to replace human testers because we still need that knowledge. It's never going to go away, even with the AI. You just need to find out how to test AI better, or at least do it. There are a few advancements again. Scriptless, test case generation, there might be some job transformations, fault prediction, and then self-healing code, which is again a lot of solutions being provided for. Why do we need self-healing? Basically, widespread industrial panic. Everyone had failures of development, everyone had failures of deployment, a lot of deployment failures, test failures, basically failures, and the fear of failure. So why do we want it? The SI. Basically, if we don't do planning, if we don't see in the long run, if we don't plan things out, if we don't strategize, we don't use things as they should be, we don't apply it as they should be or should be done, we're going to end up with bad tests, and then we're going to have the alien and yeah, things. Bugginess, flakiness. I think everyone's familiar if they ever done testing. And then what is self-healing? The concept is basically have tests that can heal themselves, diagnose themselves, and heal themselves. Healing comes in a few different formats, but the initial part is that you need to detect the changes of what's being at fault, what's faulty, what's the erroneous part. And if you can do that, then you can maybe predict about it. And then you need to communicate it to the user. You need to somehow tell the user what went wrong. Because detecting and predicting is still not enough if you don't have the user being let known. The good thing is that we can do the application and the adaptation part. The very hardest part, I think, is adaptation, because even though AI might apply themselves and might change themselves in the long run, might change themselves with deep learning, it's a bit of a conflated or convoluted system. Now, for the level of self-healing, you can do it from the very, very smallest part of unit testing to the entire biggest system testing or a lot of system integration testing. Let's call it the world testing, testing the entire world. And as soon as you start going big or going bigger and you start involving more complexities, it gets harder to reason about. So the proposal or the idea is to start small, fail a lot, and try to reason about it. And if you have a good enough reason, or you have a good enough proof, then you can progress faster. Maybe apply it to a bigger field. Maybe apply it to a different area of expertise or testing or development. But until this is happening, there's going to be a lot of convolution. Controlled and uncontrolled. Yes, componential bluffing is basically if you involve a lot of components, you're going to have a blob. You can't reason about those. Overextension is usually when we try to apply the same thing over and over again to, say, fields that might not need it or might not work that way. It can happen. The other thing is, as mentioned previously, the snake oil vendors and the not-so artificial intelligences. Usually it's heuristics and similar. And it's kind of a double-edged sword. I might let the audience figure out why I'm saying that. I'm going to let you know at the end. And here's the oracle question. The oracle question is one of the most important things in the AI part. You need to know what's the right answer. You need to know who to ask. You need to know who's going to decide things. And as you can see on the image, there's a 6 on the image and a lot of options. And if you use image recognition, it might still say, let's say, an unlock icon or a letter G. So in that sense, if we are not being there for the system and we're not guiding it at least a little bit in self-healing, it's going to end up bad. And then the prediction question. There are different levels of how to predict, and the very first is that there's no prediction, just go with what you have. Then you can have a random answer. The answer is 4. I was quick. That's fine. Poor man's solution, we might say, store up a few answers, burn through those, and then not work with it. Then, heuristics. Basically, what I've been doing at my company is right now in between the heuristics and the neural network / AI, but it's not there yet. And I think that the investigation is going into actually moving into the neural networks. And then the challenges of self-healing is maintenance. Usually for the test cases that we have on UI tests, it's the lack of IDs and visual brittleness. Or maybe we don't have enough test data. And then, again, DevOps. So the vision is AI for prediction, less maintenance and more delivery, filling up the market gaps and further innovation. And I'm really, really hoping that competition is going to surface. There's a lot of companies, and I'm not seeing competition. I'm seeing everyone siloed up and showing their products. So the future might hold things, but it's going to be an AI winter. And better algorithms, that's a given. As said, if we pass the time, if we end up in the AI winter, if we don't, in either case, we're going to have better algorithms, we're going to have better computational systems, and basically humanity is going to end up better, but I'm not seeing we can avoid the AI winter. So, do we need self-healing? Questions?
Thank you very much, István. So now we move to our questions and answers session, and I would like to remind the audience that we use our Slido tool to manage the questions, so please use the Attendify application where you find the Slido module integrated and you can put your questions there. So your first question, István, is, does it make sense from a company's point of view to delay AI testing experience and watch others fail and learn from them?
That's a good question. The initial answer would be no. Please experiment yourself as well. As mentioned, if you fail fast, do a lot of experiments, you might end up with a bunch of failures, but there might be good results. At least some results. And some of those results will be good. Some of those results were going to be, let's say, let's flush those down the toilet because those are not important anymore. The rules might not be good. But in the sense of embracing AI and doing AI testing, I think that it would be beneficial for everyone if they kept experimenting, embracing, and doing their own thing. You might be able to watch others, and you might be able to use their experiences, use their data, use their approaches. But if we do the best of the both worlds and keep experimenting, I think that's the best way to go forward. I mean, results will come only if you do things.
The next question, how do you test self-healing, the evergreen question?
Yes, that's also a good question. To test self-healing, you need to have a system, or you need to have a set of data, tests, where you know that things are as they should be. This is the initial golden phase, or the golden standard. Then you might need to do a few experiments of setting up a few errors that you might have, say something moved somewhere, something changed somewhere, and these are controlled changes. And if your algorithm is working with that and detects the right changes, then you can say that you've had, let's say, a successful test. But for the most part, you need to know what your system is doing. You need to know what your algorithm is doing. You need to get intimate with your own system. And until you do, or you use a third-party solution, you either have to fly blind and trust that the third-party solution is tested, or you test it yourself. Again, as you asked before, test it out, try it out. If it works, great.
Soft skill question. What is the easiest way to convince pessimistic manual testers to support the test automation?
Okay. Convince pessimistic manual testers. Let's see. Pessimistic manual testers, I haven't seen that too many because I think everyone likes having automation. I mean, manual testers might do less than. If we consider this, I would say that, let's say someone's extremely pessimistic. If you show the data, if you show the results of how self-healing works, or how test automation works, how many tests are being covered, how many test steps are being worked, if you see these things, if you present these, nobody can argue with hard data. They might, but at that point it's not pessimistic, it's just being, I don't know, obtuse. And I think that numbers can convince people, and results can convince people.
Okay, the next one is really a funny question. How much wood could a woodchuck chuck if a woodchuck was an AI?
I asked this yesterday as an evil question, so thank you for repeating it. I would say that as much wood as the AI could.
Good answer, thank you. The last one, is it not just creating always passing tests?
Yes, so as mentioned, there's a, let's say, hidden question or hidden implication in the presentation. I didn't outright spell it, but what you're asking is basically, is it always going to pass? In a sense, yes, but this is the thing. This is actually creeping tech debt. If you let this happen and you don't have a system that's going to know that at some point we've reached the point where it's not acceptable anymore, you're going to have a bad time. You're going to, say, have a flag in a test that you wanted, say, the British flag, and then you end up with Kuala Lumpur's flag. Maybe the flag changed to a button, maybe the flag changed to an entire division, and you still had the test passing because what your self-healing did and no control was there, it's still passing. So basically this is tech debt, and you should be very aware about it. You should really, really, really be on the edge about it, and you shouldn't let the system do any of that. You should control it as much as you can. The system is allowing that, and self-healing is allowing everyone to do that, but as long as you don't pay attention to it, it's going to, let's say, go off the rails.